All right, so let's get started. It's 101. Welcome everybody to our Alternative Berry Production Systems webinar series. Today, we have three great speakers that they will be covering the topic of organic pest management strategies for June-bearing strawberries. We have Dr. Leslie Holland, who is an assistant professor and a fruit plant pathologist at UW-Madison. Dr. Jed Colquhoun, who is our wheat specialist and a professor in the Department of Horticulture, and Dr. Christelle Guedot, the fruit crop entomologist and an associate professor in the Department of Entomology. So I just want to give a couple of instructions about how we're going to be managing the questions. So you can ask questions in the Q&A. You can find that if you move your cursor at the bottom of the screen. You'll see a little menu, and you can add your questions in the icon that says Q&A, or you can also add it to the chat, and we're going to be monitoring those. And we're going to be asking most of the questions at the very end so that we don't interrupt the speakers. But feel free to do that. And we're also going to have a poll right before we start with the Q&A after the third speaker is done. And so just feel free to add all your questions there, and if there's anything I can answer in the meantime, I could help with that as well. If you have any problems with finding where to put your questions, or you have anything that you want to ask me in the meantime, I'll be monitoring those. So with that, I'm going to stop sharing my screen, and I'm going to allow the first speaker, Dr. Leslie Holland, to take it over.
Great, thank you, Amaya. Hopefully everyone can hear me and see my screen. Awesome, getting the thumbs up, perfect. Well, good afternoon, and thank you for attending our webinar today, trying to investigate or discuss, pest management issues in organic June-bearing strawberry production. And I will be handling the disease portion of this for today. Okay. So strawberries are afflicted by numerous types of diseases that are caused by numerous types of pathogens. For instance, we see here fungal diseases causing leaf spots, fungal diseases also causing issues on the actual fruits themselves, as well as the roots. Here we have fungal and oomycete diseases. Just minimize that. And so all of these diseases can cause issues to the entire plant, and they don't often come one at a time. Sometimes there could be multiple diseases affecting a single plant or a single field. And so really something to focus on, especially as we think about organic disease management, is the total health of that plant. So how do we manage diseases? Well, first it starts with scouting, trying to figure out what we have in our respective fields. And why do we scout? Well, first to prevent unnecessary pesticide applications, right? If there's little to no disease pressure, that application may not be warranted. Further, we're trying to identify potential problems before they become beyond the point of management. And so here in the graphic below, I'm showing you a table, and perhaps Christelle will show you the other half of the table where it talks about insects, but I'm just focused on diseases for today. And this comes from the Bio-IPM Strawberry Guide that was put out by UW-Madison in 2014. And so this just shows you kind of a typical season for June-bearing strawberries and different times within that season that you're going to be scouting for respective diseases. So if we take a look at the top two, red steel and black root rot, these are diseases that impact the root system of strawberries. Typically, we're going to see these in the spring, usually when the springs are typically kind of wet and rainy, as well as back in the fall, again, kind of those same conditions, wet and rainy, where these pathogens are able to really thrive in the soil and infect roots. And before I dive into some of the different diseases, as well as management of those diseases, I want to talk about the disease triangle, because this will help us establish why we choose to manage the way we choose to manage. All three things, susceptible host, pathogen, and a conducive environment are needed for disease to manifest. And all of this happens across different timeframes, right? Sometimes in certain parts, certain times the pathogen is present, and this also then will dictate the timing of our applications in order to manage, or the timing of our cultural practices for management. So all of these things need to be present for disease to take place. And as we think about that in terms of an integrated disease management program, what we're really trying to do is modify or manipulate different aspects of those components of the disease triangle. So first, looking at cultural management, this could be crop rotation or sanitation. This is really trying to reduce that conducive environment for the pathogen, not giving it tissue to live on, whether that's old tissue from your strawberry plant or non-host of pathogens that are being rotated as crops. There's also soil drainage, air circulation, and weed control. All of these cultural practices can contribute to decreasing the conducive environment for those different pathogens. Thinking about resistant varieties, removing the susceptible host, that seems kind of like an easy one. This really should be the first target when establishing your new plantings, is focusing on resistant varieties. And this will be the key to managing most of the diseases that we talk about today. And many pathogens are opportunistic. And so there's really nothing particularly special about a lot of the pathogens that you will encounter. They aren't really strong and able to overcome a lot of challenges. Really, they're seeking out plants that typically are already stressed. So whether that's winter injury, waterlogging from too much water sitting in the soil, these pathogens are after some plants that are already in a stressed condition. I just put this table here, and I provide you the reference at the bottom of where you can take a look at this, but this is just talking about disease susceptibility among different strawberry varieties. A similar table is also provided in the Midwest Fruit Pest Management Guide for various strawberry varieties, and it just tells you really from resistant to susceptible to tolerant for the respective diseases across the top. So just there for your reference. And then kind of that last component of our integrated disease management program is looking at chemical and biological controls. And of course, chemicals, for the purposes of today's talk, I mean chemistries that are registered organically. Example would be copper, and these are intended to control or suppress the growth of pathogens. Similarly, biologicals can also have a suppressing action to pathogens, and these can come from beneficial microbes or plants. Something important to note is that currently there are no reliable biological control products that have been developed for managing strawberry diseases. So there are biopesticides that are available and have been shown to be effective in a very low disease situation. And this particular management approach is targeting the pathogen and also that conducive environment, right? Making the environment less hospitable for a pathogen to survive by putting these antagonistic things like copper or biologicals in place. So the first disease that I'd like to cover today is black root rot. And I think this has been a disease that's starting to pop up a little bit more, it sounds like, in some of the berries. And it's a disease complex. So that means it's caused by a multitude of things, including several pathogens like fungi and nematodes, but also contributions from things like freeze injury, waterlogging. I've even heard issues with drought. So this is kind of a complex and complicated disease of strawberry plants, typically affecting the root system. If you are planting or growing strawberries on heavier clay soils, you're most likely to see fungi, whereas on sandy soils, you're most likely to encounter nematodes, kind of or oomycetes, or water molds, I guess, as we call them, causing those disease symptoms. It can reduce your plant vigor, and your production will decline in severe cases. And this is typically common in fields where strawberry has been planted back to back to back. So managing black root rot. Well, culturally, pre-planting soil testing for nematodes is really crucial to determine kind of what you're starting out with. If you find that you have high disease pressure for nematodes, that might not be the best spot to plant, or that might be a spot that is maybe warranted for some type of organically certified like biofumigation. Proper soil drainage, raised plant beds to allow soils to dry out, crop rotation, and management of other diseases such as red steel. Oftentimes red steel and black root rot, initial symptoms can be quite similar, and their management culturally is also quite similar because they tend to involve water molds, which really thrive well in these high moisture, high water environments. Unfortunately, no resistant varieties are known for black root rot. Some of these varieties do tolerate stress better than others, and those would be the ones to lean towards. Particularly susceptible varieties are also listed. Chemical and biological management, since there's no single cause of disease, that means there is no single means of control. And so spring application and fall application of respective products based upon your causal agent are recommended. Something like common leaf spot, lesions start as pictured here. They start as purple, eventually turning white in the center. This typically affects young expanding leaves, and severe infections can defoliate, but the plant can tolerate a mild infection. The fungi does overwinter in these lesions you see on the leaves, and living leaves are in the debris. And this disease is also favored by moisture and can increase the susceptibility to winter damage. Managing this disease includes destroying the tissues that it's living on, those infected leaves, promoting air circulation. Varieties differ greatly in susceptibility, and again, I will turn you back towards that table of resistant varieties. In terms of chemical and biological control, early season applications when conditions are most conducive is the best timing, and there are various copper formulations that have been shown to be effective. For something like botrytis, this initially appears as tan spots and then expands into kind of this grayish mold that you see pictured here to the right. Previous seasons, dying leaves actually harbor the fungi. So again, in terms of management, we're thinking about trying to get rid of those tissues harboring those fungal pathogens. It can develop quite quickly and also can continue into post-harvest as a disease. And again, it's favored by moisture, as we're starting to see for a lot of these diseases. Reducing that canopy humidity, harvesting more frequently to reduce overly ripe fruits remaining in your field, and removing leaf debris to prevent overwintering inoculum. There are no known for resistant varieties, but there are varieties that are less impacted. And chemical and biological applications are most critical at the bloom period. Some are warranted as fruit ripens, depending upon your disease pressure, but that bloom period, the blossoms are going to be the most susceptible to infection. And anthracnose fruit rot caused by Calotoptricum species can infect both the green and red fruits of your berry, and it can develop quite quickly here in the upper Midwest, especially if conditions are warm and rainy, which can be quite typical. You might see orange coloring within these lesions, which is indicative of the fungal mass growing there, and that fungal mass can spread via splash when rain events occur. Managing for anthracnose fruit rot, straw mulch can really minimize that spore splash, provide air circulation, again, as we've seen for something like botrytis as well, and regulate planting density. Anytime you're creating a very dense planting, you're creating that microclimate in which many of these fungal pathogens can thrive. Again, no known resistant varieties, but there are some that vary in their susceptibility. In terms of chemical and biological management, chemicals can be applied to both green and ripe fruits, and there's been success documented with copper products. So making sure I stay on time, I just wanted to quickly highlight some of the different, some of the newer research that has been demonstrated that various regions throughout the country, and actually including Canada, I think for that second bit of research, that might have implications for organic strawberry production. And I put this in here despite the fact that they were demonstrated in conventional systems. They rely on things like thresholds, or this last example relies on UV light for the management of diseases. So this first one is validation of a strawberry advisory system. And with this, they were able to reduce the number of sprays, and but also noted that sprays definitely need to be made in advance of rain being in the forecast. So, but able to reduce the number of sprays, whether they're organic or conventional, is quite beneficial. Additionally, other action thresholds for something like common leaf spot also reduce the number of fungicide sprays in a conventional system. And most recently, UV light has really come through in its ability to suppress powdery mildew growth, not only in strawberry, but other berry crops as well. So this is exciting stuff to think about moving forward in organic strawberry production. And so the take home with all of this, I know that was a quick overview of a lot of things, but really the take home is plant disease-free plants, also plant varieties that are disease resistant or disease tolerant, use crop rotation and sanitation as means to make environments less conducive for the pathogen, prioritize soil drainage and air circulation, soil test if that is available to you to get an idea of what your planting site is starting with, control weeds, straw mulch if possible for anthracnose especially, and pick fruit frequently to reduce ripe fruits remaining in the field. So with that, I think I'm at 15 after, and I will stop sharing my screen. Thank you for your time and attention.
Thank you, Leslie. If you have any questions for Leslie on her presentation, please type it either on the chat or on the Q&A. There was a question about whether we were going to make these slides available. What we will make available is the recording of the webinar that we will be posting in the respective websites of UW-Madison and UMN, and also the YouTube channels that we have. We'll put the address to get to those, and we're probably going to send an email to everybody that registered with the link to those videos. All right, so our next speaker is Jed Colquhoun, and he's going to be talking about weed management. So Jed, take it over.
Thanks very much, Amaya. Can you see my slides?
Yes, we can.
Great. Thanks very much to all of you for joining us this afternoon. My charge today is to talk a little bit about organic strawberry weed management. As Amaya mentioned, my name is Jed Colquhoun, and I work in commercial fruit, vegetable, and other specialty crop production here at UW-Madison, including crops like hops and mint and such. And I mention that as context because of all the 24 crops or so that I work with on an annual basis in research and outreach, I have to be very candid in telling you that it's about as daunting as it can get in terms of weed management in organic strawberries in particular. Not only do you have limited number of tools and strategies to be able to use for weed management, but the crop itself, based on its biology, presents some challenges in using those tools realistically and practically in production. So I apologize that I don't have any silver bullets to share with you today, but I think it's worthy of a reminder of the options that you do have that you might be able to put together holistically into a season-long or multi-season approach in perennial strawberries. So what are the real challenges based on the biology of strawberry itself? Number one, it's a perennial crop, not unlike something like a grape or a tree fruit, of course, that presents challenges to begin with. That offers us in the production years some really limited cultivation opportunities, particularly within the crop row, where weeds not only reduce yield and quality, but make it hard, particularly in U-pick operations. In strawberry, though, we have another biological challenge that complicates our weed management approach. And that's in the renovation, which adds another layer of challenges. And then subsequent to renovation, when the daughter plants in that fall present and grow the next crop for the following harvest. That really limits our ability to use the number one tool in any organic system that I've worked in, and that's the mechanical advantage, whether it be hand weeding or cultivation. We have to be very careful to allow the daughter plants to establish themselves and support a crop in the next season. So let's work through from planting, or actually prior to planting, which is probably your most important time to consider strawberry weed management, all the way through the harvest years. And I cannot emphasize this enough. The number one concern that I hear from strawberry growers is, how do I control a weed that was already there prior to planting the strawberries? Typically perennials like the Canada thistle that you see in the slide today, or yellow nutsedge, or even some biennials that often act like perennials. Like lately, the number one question has been white cockle. We cannot control those weeds even well in conventional strawberry production, and it's even worse in an organic system. So by far, avoidance is your best long-term strategy. And to do that, what we tell people is choose your fields very wisely, avoiding fields that have a history or a presence of perennial weeds, because they're going to be terribly difficult to control in a perennial organic cropping system. So if you're in a rotation that might include things like grains or corn and such, that offers more opportunities for cultivation and elimination of these species prior to planting your strawberries. And so focus on competitive crops in the years coming up to organic strawberry production so you can come into this as clean as possible. The other option is to use a stale seed bed. The competitive crops help us in particular with perennial weeds. The stale seed bed itself helps us with annual weeds. And this is based on the principle that for most annual weed species, the vast majority of the population germinates within 2 to 3 years after seed production. So you may be able to eliminate 60 to 70% of the perennial weeds by stimulating them, or I'm sorry, of annual weeds, by stimulating them to break dormancy at a time when you don't have the crop in the field. We have that liberty in transplanting strawberries because we do it a little bit later in the season than something like growing peas, for example, where we plant as soon as we can. So in a stale seed bed, we prepare that seed bed about 3 weeks prior to transplanting the strawberries, allow the weeds to germinate, do everything you can to grow a good crop of weeds, even water it if necessary, and then destroy those young emerged weeds in the organic system. That's typically done with flaming or very shallow tillage. You don't want to bring up the next crop of weeds with deeper tillage, and then plant with minimal soil disturbance. And on the screen in front of you, on the left-hand side, you can see an area where that stale seed bed has been implemented and then flame weeded, as opposed to what the population would look like if you had planted the strawberries and these came up after transplanting. So again, provides us about a 60 to 70% advantage. That doesn't mean you won't have weeds, but you'll have a lot less coming in clean, trying to eliminate some of those annual weeds prior to transplanting. And then we get into cultivation. Again, mechanical advantage is our greatest asset in any organic system. And we have a few different options in organic strawberry production. In the planting year, we focus on in-row weeders. We've had different tools like the Eco Weeder, Regi Weeder, even some more aggressive tools like brush hose. And in that time, we can focus on the in-row weeds and establishing a clean strawberry crop because we're not as worried yet about the daughter plants immediately after transplanting. At renovation time in the established years, that's prime time for cleaning up weeds. And in an organic system, that generally starts with mowing that prevents seed production, followed by tillage as we move the strawberry row over, as well as to eliminate some young weeds after germination. The key there really is to prevent weed seed production. By mowing, you want to set these annual weeds back enough that we hope to get to frost before significant seed production. But it's important to note that that tillage operation itself can spread perennial weeds. Keep in mind, a Canada thistle colony 30 feet in diameter has about 10 miles of roots under it, and a 1/4 inch section of Canada thistle is a clone of every other weed you see out there. So tillage can spread those 1/4 inch sections around. And then as we get into the established years, like you see with the Lilliston spider gang on the right-hand picture, we can use more aggressive tools at renovation. Some of those will throw soil into the row to cover young germinating weeds. So we have some additional options as we get more aggressive in the harvest years. Post-emergent control in strawberries is very limited to really 2 options, and both have advantages and disadvantages. Flame weeding is one that's used quite often. The advantage really, it keeps the soil structure intact, no soil disturbance, so we're not disrupting the soil organisms, and we're not stimulating new germination of annual weeds. Those decaying weeds, believe it or not, are like a cover crop, and they can add some organic matter. And it gives us immediate control of small annual broadleaf weeds. So they have to be quite small, and we're not burning them to the ground. We're breaking cellular membranes, basically, that cause them to die. The disadvantages, though, comes at a pretty high cost. And if we're considering sustainability, of course, we need to consider the fossil fuel use in that case. Flame weeding will not control perennials well, or grasses, because grasses have a growing point below the ground until very late in the system or in the season. And keep in mind that this is really a non-selective tool. So strawberries will also be damaged. So a lot of folks will use a hand flame weeder between the rows to eliminate those young annual weeds. And as I always tell people, it's exciting, but it's also dangerous. It's something to have fun with, and you get some immediate gratification of good weed control, but it is a large burner traveling through a field. We also get a lot of questions about using organic herbicides, everything from the acetic acid type products to things like Weed Slayer and such. These are contact burn down products to control very small broadleaf weeds in particular. Contact means the herbicide doesn't translocate in the plant, so it can't get to a growing point on a grass or into the root system of a perennial. There's no residual after you apply it. There will be no control subsequent to that in the field. It doesn't persist in the soil. Grasses and perennials like flame weeding, they're not controlled, again, because it's a contact herbicide. And I just want to remind people, based on some recent experience on the Pacific Northwest, this is still a pesticide. It needs to be registered and needs to be labeled for such use. And again, a lot of these are non-selective, so they'll injure strawberries as much as they would injure the weeds. My general experience, we've done a lot of research. Our plots are on the left-hand side here. And looking at these contact products, if the broadleaves are extremely small, you can often burn them off. But anything with any sort of size to it, inch or two greater, like the pigweed in the right-hand picture, it'll be contact burned, but it regrows quite significantly. So it can give a little advantage, but these are not silver bullets at all. And there are a lot of products out there that will do this, well, they'll set the weed back a little bit. Mulches, they're really, along with mechanical cultivation, that fall mulch, and then a thick enough layer is just a wonderful way to control weeds between the strawberry row, in particular when you pull the winter mulch off and it sits between the matted rows. But I would just remind you to consider the source and make sure that it's weed-free straw mulch. And I'll give you an example from my colleague Hillary Sandler in cranberries. And cranberries, they spread sand on the winter ice for vine management to promote new vine growth as a cultural way to stimulate cranberry production. But what Hillary found was that sanding was a weed seeder in itself. They found 74 weed species in their sand piles from 23 plant families, and 79% of those were considered their primary target weeds in cranberries. Again, that's a different system, but that's exactly what we need to avoid with the straw mulch in strawberries. Make sure it's weed-free, know your source, and ask them if they have any sort of weed issues that could persist in seed or vegetative tissue when you mulch the strawberries. So putting that all together, we want to start cleaning new plantings. I can't emphasize that enough. Use competitive crops to eliminate the perennials, a stale seed bed to get ahead of the initial shot of annuals. We then cultivate through the first summer with in-row hand weeding, and then get into that fall weed-free mulch when that's pulled back in the spring. That allows us to hand weed, hoe, or selectively flame weed those weeds that grow through the mulch. And then we get into the renovation post-harvest timing, where we can mow and till and be quite aggressive with the crop in reestablishing it, but that allows us an opportunity to prevent weed seed production. And then we cultivate again until that fall mulch is put on to protect the strawberries, and continue the cycle next spring. So what does the future hold? In the last minute or two, I just want to give you a sense that there are some new things coming. They may be a ways out, but there's hope for maybe a little more of a silver bullet than what we've seen in the past. A couple of pieces, one that we're working on in our lab that actually we put out plots for yesterday that we're very excited about, is using natural plant growth regulators. Some of these are OMRI approved and available in organic systems to trick weed seeds, basically, of our annual weeds. This is an example from Palmer amaranth. And we're doing this in two different ways. One, to promote weed germination, break weed dormancy, like in a stale seed bed. So the majority of them will germinate fast and allow us to kill them before they're competitive with the crops. Or in some cases, we're promoting dormancy when weeds are not easiest to control. So during the production system, can we push those weeds to germinate late in the summer or early fall? So they're actually killed by frost and freezing before producing seed. And this is one that's out there a little bit, but it's been a lot of fun to play with, and we see a lot of hope moving forward. And finally, there are some technologies out there that will have application soon in organic weed management in general. Number one, remote sensing allows us to detect, even from a satellite, the signature of plants and different species so that we can be selective about removing weeds and not the crop. And then the automated technology to be able to actually do the removal would follow with robots, many of which are solar powered. They incorporate that signal from a drone, plane, or satellite in hyperspectral imaging, and they know the difference between the crop and the weed, and they can go and selectively remove it with anything from sandblasting to mechanical cutting and such of just the weed itself. The beauty of a robot is it works 24 hours a day and it doesn't complain. So they could make awesome hand weeders in some of our systems. So these are coming along. In the left-hand slide, that's actually in grains in Europe. And it's not far from what we have delivering food during pandemic times on campus. The same robot technology traveling around delivering lunches to our students, faculty, and staff. So it's not pie in the sky, it's on its way, and we look forward to welcoming it as another option in organic production systems. And with that, I'll stop sharing my slides, and thank you very much for your time.
Thank you, Jed. And if you have any questions for Jed, just please go ahead and either post them in the chat or the Q&A. And we're going to move to our next speaker, Dr. Christelle Guedot. So Christelle.
All right. Hi, everybody. I'm sure you can all see my screen. And so I'll get started and I'll talk to you all about insect management in organic strawberry systems. So again, we're focusing here on June-bearing strawberries. And the insect complex that we have in June-bearing strawberries it kind of spans through the fruit and flower feeding pests that you can see here. We have root or crown feeding insects that you can see down here. And then we have more of the foliage or stem feeding pests. And you can see we have quite a few, but that doesn't mean that people have to deal with those insects all the time or that they reach economic level. They just can be present, you might see them. So of course, I'm not going to cover all of them. We would need a lot more time. And so I kind of give you a little sample here on the insects I'm going to talk about. We'll talk about tarnished plainbug and spotted winged Drosophila because there's no talk on small fruit that can not include spotted winged Drosophila. We'll talk about weevils for the root feeding insects. And then two-spotted spider mite is another one. There's a lot more I could talk about, but that's what I will be focusing on today. And as Leslie mentioned, in our bio-IPM strawberry book, we have a calendar for our insect pests and diseases. And she showed you the other side of that. But it's really essential to monitor, sample and monitor. And by monitoring, I mean not only seeing when they're present, but keep track of the numbers, because that's what's going to determine whether or not you're reaching what we call economic thresholds. So it's very important to know the life cycle of your insects and know when they're going to be present and what kind of numbers we're looking at to think about those kind of management strategies when you really reach those high numbers. And for insect management, of course, we are covering the similar kind of management strategies that we talk about in conventional, that we talk about for diseases or weeds. And of course, in organic production, the goal is to really focus on prevention and having those strategies that are going to help us prevent those populations from reaching those economic thresholds that then lead to chemical control. So We're going to think about cultural management, whether it's how you irrigate your crop. Some insects like very dry conditions like thrips or mites, and maybe a better irrigation is something that's going to decrease those populations. But also trap cropping, exclusion netting, or crop rotations are going to be very important things and depend on the insect that you're looking at. Host plant resistance is also something looking at varietal susceptibility that is very important, as Leslie mentioned, in disease management. Not as much with insect management, but I will touch on that for some insects where it's relevant and something to really consider. And then really when we go into control, so after we talked about those kind of avoiding having the population to build up, biological control is one that you really want to try to rely on when you're talking about organic. And so there's two approaches really that we're going to be talking about, is augmenting with commercially available biological control agents, or conserving your biological control agent by fostering the existing populations you have. I will not go much into chemical control. I will give you names, but I'm not going to go over all of that. But in OMRI approved insecticides, we have azadirachtin, that's an important one that has mixed results depending on the insect we're looking at. Chromobacterium, that's also organically approved. The name would be like Grandivo. Those are going to be better for your lepidopteran insects. Pyrethrin, that's your pyganic. That's a common one that's used. And spinosad is your entrust, that are also commonly relied on for organic. There are others, of course, I'm not covering them all. But there are some essential oils that people have looked at, and soaps that are, and mineral oils that are also important. And so I'll give you some references on that. There's at the end of the talk, I have resources, and you'll see more of those details in those resources. So we're going to start with tarnished plant bug. And really the reason why is because for the most part, it seems to be the most predominant and important insect pest in strawberry production in the Midwest. So our tarnished plant bug has multiple generations per year, but we're only going to be looking at really the first generation, the adults that are emerging and the first nymphs that are coming out. They're highly polyphagous, and we can use that to our advantage. So it's important for you to monitor those insects, and there are different thresholds that you can use, different methods that you can use. The damage symptoms are here. It's this apical seediness and cat facing that the berries will experience. And so you can do sweep netting, and there's thresholds for that of 4 adults per 20 sweeps. You can do tapping of the flower clusters, like you can see down here, onto a plate and count. And then also sticky cards to look at the movement. And what's pretty well known is that, when you, if you have a neighbor that has alfalfa, you're going to have an influx of ligas that are going to come into your, or tarnished plant bug, ligas is the scientific name, that are going to come into your strawberry. And so where it's important to think about from a management standpoint are going to be your cultural control methods are going to be very important for tarnished plant bug in organic production. We're talking about controlling those weeds that are around. The broadleaf weeds are hosts because they're very polyphagous. So mowing those when you have bloom and small berries is not something you want to be doing. You want to be avoiding that movement from those other hosts that they like onto your strawberries. So avoiding that is important. Trap cropping with alfalfa is one that I'll talk about because that's a study that we're conducting in my lab currently, and I'll show you the first year of data we obtained last summer. There's also been work done with varietal susceptibility, and before I forget, there's also mulches that have been assessed, and by that I mean plastic reflective mulches with tarnished plant bug. And that has been a little bit of a mixed result with that and hasn't been really implemented. That was done about 10 years ago and is not really implemented by growers. So that's why I'm not going to go over that. On the varietal susceptibility, there's been some cultivars like honey hoy and also highly productive cultivars that by producing a lot more kind of dilute the impact of the damage. And so they're not really resistant, but they're producing more. And so because you don't have a higher population, you have lower effect damage in those cultivars compared to other cultivars that don't produce as much. There's not really any biological control agents that are effective. And then here you can see some of those chemical control that are somewhat effective, pyrethrins being really the lead on those chemical control if you reach those levels that I just talked about before. So on tarnished plant bug management, we have the strap crop that I mentioned, and this is my student that was looking at planting alfalfa on the side of the strawberry here, and then down here, this is the control, and this would just be the regular turf grass that's planted on the side. And so just want to show you quickly some results. Here on the y-axis, we have the number of tarnished plant bug that were sweep netted. And here on this part here, this is the perimeter. So this would be either the grass or the alfalfa that we put as a trap crop. And this will be the different rows of strawberries. So the first row next to the alfalfa and further into the field. And really the bottom line of this is that you had, and this is the control in blue, and this is the treatment. So where the alfalfa is present in that kind of yellowish color. So you can see we have a lot more tarnished plant bug in the alfalfa compared to the grass next to the strawberry. But then when we go into the strawberry itself, every time we have the alfalfa, this one, this one, this one, and this one, we have a lot fewer tarnished plant bug than we did in the control treatments, those blue bars here. So overall, we had a decrease in the number of tarnished plant bug. It was a 60% overall reduction in the strawberry compared where the alfalfa was present compared to where it was not. And so this was very optimistic for us, and we are repeating this in this study this summer. But hopefully this will be something that can be easily implemented by growers, because you just have to saw a little bit of alfalfa into next to your strawberries, and it will regrow. And then, of course, you don't want to mow that, and that's really important to think about, because then you would have some of those plant bugs that would be moving into your strawberry. So quickly moving on into root weevils, that will be those insects that attack the root system. Just one example, it's kind of a complex. There are multiple of those weevils that can be present in strawberries. For the most part, they all do about the same, which is the larvae are doing some damage on the roots and the crowns. The adults feed on the leaves at night. They actually can't fly. And so they rarely cause economic damage. And the adults is really not the main damage. But indeed, if you have heavy infestation, you can have an issue with yield. And so because they do not fly and because they are present in the plants and at the root system, what's really interesting here, the main strategy for those and also for strawberry rootworm would be to just rotate out of strawberry for at least a year. That's the main really management strategy that you can do. When you have high population, just rotate out of the field, go somewhere else, wait for a year, and then you can plant again, because they don't fly, they're gonna die, and you're not gonna have a problem in the future. On biocontrol aspects for root weevils, we have entomopathogenic nematodes that you can purchase, and you would release those in the springs. And these have been shown to do decent control of those rootworms. But again, you have that option of rotating out, and you rarely reach those economic levels where it would justify the chemical control that is down here. That's really not used so much, the chemical control. But those are some that you could consider, but there's not much efficacy data on these, especially those essential oil like garlic juice or any of those. Spider mites is another one that you might see. They have, they look like this. They have these two spots. They're very small. They feed on the underside of the leaves, and they kind of cause discoloration, the bronzing that you might see on the leaves. So again, they don't attack the fruit. They really mostly attack the leaves. They might then have an impact on the fruit and reduce plant vigor. But they're pretty much localized infestations. And with these insects, actually mites are not insects, but whatever. What is important is, again, the cultural control practices, renovation of the beds to remove their food and their habitat, It's also an insect that likes very dry conditions. So providing adequate irrigation and not over-fertilizing is going to help decrease those populations. What's important with mites is that for the most part, they are taken care of by naturally occurring biological control agents. And those are actually predatory mites. And so if you are careful and you don't overspray, because when you spray, you tend to kill the predatory mites and not the pest mites. So it's better to consider leaving and not spraying, if you have mites, leaving the naturally occurring predatory mites take care of those pest mites. And one way of seeing that is they usually are a little bigger and they move a little faster than the pest mites. And if you have one predatory mite for 10 pest mite, that's actually enough to have good control of those populations. And in general, they will take care of them. But you can also buy them commercially for augmenting your populations. You want to be monitoring if you start having high populations. So you have thresholds here of the presence on more than 25% of the leaflets that you sample. And that's when you would think about applying chemical control. There are several chemical controls or mineral oils, insecticidal soaps, essential oils that you could be considering if you really need to spray. But again, that's always the last resort and trying to get the predatory mite to do the job for you. The last insect I'll talk about is spotted wing Drosophila. I just want to mention it because you might find yourself in the situation of having some, especially towards the end of your harvest. And so this is a fly that attacks ripe and ripening fruit and turns the fruit to mush. So it's something that's important to be aware of and pay attention to. For the most part, when we have June-bearing strawberries, they do not overlap. Like by the time we're done with harvesting those, spotted wing Drosophila populations are barely starting to really build up. And so we sometimes have a little bit of overlap, and that comes close to when people are about to close their operation for the summer. So it's been pretty good that strawberry growers have been able to avoid the peak of the population. But you need to be aware of that shifting based on temperature, right? Our insects are cold-blooded. And so if you have a warm spring like we're experiencing now, it's possible that those populations will show up a little bit earlier. Luckily for us, the plants also do the same thing and ripen faster if it's warmer. But you have to be always cognizant of that timing, maybe sometimes getting close to overlapping. So there's different cultural control strategies that are used by commercial organic growers. Timely harvest, removing overripe and damaged fruit, sanitation, planting early fruiting cultivars. Again, if you're talking about day-neutral strawberries, you are going to be then having strawberries at the time where you're going to have spotted wing Drosophila. With June-bearing, we are with the earlier fruiting cultivars. Not really anything on the biological control agents yet. Physical barrier, that's a picture here of having netting to prevent those flies from reaching the fruit. That's an option that's been shown for other, like blueberries, for example, where it works pretty well. And then chemical control is something that organic growers have to rely on for spotted wing if they have problems with them. And spinosad and pyrethrins and the chromobacterium, that Grandivo, are the best bet that people are using. And the spraying, once it starts, is pretty intensive. But growers have been successful, organic growers, with those cultural practices for spotted wing. So as a take home quickly, crop rotation for your white grubs is the main strategy that you want to think about. Sanitation is important. If you have infested fruit, you want to remove it, especially for spotted wing Drosophila, for example. Fostering your biological control agents that are naturally occurring is going to be very important. That's something that you really need to think about when you're spraying, when you're trying to manage populations, to have populations stay below levels that are harmful. And then if you have to spray those armory insecticides, that's the last resort. And you want to be very mindful of pollinators, because you constantly have flowers and you're going to have pollinators for a longer period of time. So you want to be very mindful and spray in the evening if you can. And then these are just the resources I wanted to give you at the end. This one, from Cornell is really good, and that's where you'll have a lot of those kind of efficacy data for the insecticides, meaning the oils and all those options that you have there. And that's it.
Thank you, Christelle. We have a couple of questions, but before we go and we answer the questions, I just have a quick poll here that I want to launch and get people to answer if possible, while some of the panelists can look at the questions. Christelle, most of them are related with insects. So I'm just gonna launch the poll here, and then we can go ahead and answer those questions. And also in the meantime, if you have any other questions, please just feel free to keep typing in there. We'll answer them once we're done with the poll. All right, so maybe in the meantime, as we let people answer the questions in the poll, I could ask, we have two questions here in the Q&A. One of them, Sam asked, what about cyclamen mites?
Cyclamen mites?
Yes.
That's a good question. I haven't looked too much into it. I mean, it's another mite. So a lot of those strategies that I mentioned, right, are going to apply. It's not one that we see so much here. I don't know if you are seeing a lot of those populations, but a lot of the strategies from the standpoint of predatory mites and trying to foster that and trying to not spray too much and then applying those same kind of pesticides is probably going to be your best bet. But again, go to that Cornell resource that I mentioned, because that one is going to be very helpful with strategies that you can use specifically for cyclamen mites. So I don't have a good answer, but similar to what you would do for two-spotted spider mites.
Right, thank you, Christelle. Then the next one, I think this was posted as you were talking about spotted wing Drosophila, and it says, do these insects only apply to June-bearing strawberries? So it might be related to all of the insects that you covered in your talk today.
Yeah, so from the most part for, they will be there. I mean, it's not the one insect that I wanted to talk about and I didn't have time is, for example, eastern flower thrips that will come from the winds and from southern states that don't overwinter here. All the other insects overwinter here. So they're likely going to be the same complex of insects that you're going to have in day neutral strawberries. But the advantage that you have advantages and disadvantages, but the insects are going to be the same for the most part in June bearing or day neutral, and tarnished plant bug being an important one, and spotted wing becoming more of a problem if you're talking about day neutral strawberries.
Perfect. Then we have somebody commented about spotted wing Drosophila. This is Andrew, and put it in the chat. He says, we had spotted wing Drosophila once in our Malwina. I think that's some cultivar. A late June bearing that ripens in July. So maybe that is referring to the fact that you said that this is mostly spotted wing Drosophila is mostly a problem with late fruiting cultivars.
You guys up there always have something for me. You always throw a curveball for me. Greg used to do that, and now it's Andrew. But this wild family, I know you guys. Yes, it's true that the some cultivars are going to be affected in late June, but I don't think it's a cultivar difference. You might see that, and that's very possible. It happens where people observe that, but overall, there's not anything that would be clear where one cultivar is more susceptible than another. But I don't know, you guys must have a microclimate up there, because every time I say if you have June-bearing raspberries, you don't have spotted wing, and you guys have them. And now you're giving me the curveball for strawberry. But it is, again, late June, early July, depending on where you are, the populations might have already started to build up. And so that's the problem, is it's not fall-proof that none of those June-bearing cultivars are not going to be affected. And so if you have some that fruit a little earlier, you might have a problem with that. Thanks, Amaya, for putting the link.
Yes, I just put the link there in the chat for our website, where you can find multiple resources for strawberry, but there's the guide, the Cornell Organic Guide for Strawberry Production. It's in our website there.
It's great.
We have another question here. Says, I order Entrust for spotted wing Drosophila and Mustang Max. The label says that they both kill in the same way, so don't use them more than twice. Is this correct for us? What are other alternates to use?
Okay, so I'm not sure I'm going to answer all the questions, but I just want to make sure that here we're talking about organic production. And so Entrust, yes, that's your organic production insecticide. I don't think you're limited to only 2 applications, but I haven't read the label in a little while. So if that's what you read, that's likely to be true. I'm going to focus on organic production, so to not muddy up everything here. So as far as spotted wing, and even for other insects, Pyganic would be another insecticide that you can spray. If you're talking specifically about spotted wing, Entrust is really the only one that works. But there's already been sign of resistance in some population to spinosad. So what has been, because it's the only one that really has efficacy, what has been talked about and pushed, and I've done that for the last several years, is all of us, is rotating. So you want to rotate with another chemical really to keep the efficacy of your Entrust, of the spinosad. Otherwise, you're going to lose efficacy. And then we're left with others like Pyganic or that Chromobacterium, the Grandivo that I mentioned. And there are others that are not really effective, but you have to rotate them to keep the activity of your Entrust. And the Mustang Max, that is not approved organically. So please be careful with that. Does that kind of answer the question, or am I missing something?
I think you cover it. So if there's any follow-up questions, just please go ahead and type it in the Q&A. Somebody posted in the chat, Sam says, best to harvest often to avoid spotted wing Drosophila infestations on late SB. I don't know what that stands for.
That is definitely the management strategy for organic production. It's going to be to harvest every 1 to 2 days. At 3 days already, you start having third instar larvae. If you're every 1 to 2 days, you have either very eggs or very first instar small larvae that you won't see. And that's how you can kind of keep up, but that doesn't mean that's foul proof and you won't have any spotted wing in there. And then one thing I didn't mention, because we don't have enough time, is of course, refrigerate the fruit and tell people to refrigerate their fruit. Otherwise, everything keeps growing. If you refrigerate, you kind of halt the growth of those larvae and the hatch of the eggs. And so then ignorance is bliss.
Perfect. Then we have Andrew also asked, have you studied Ecotrol or potassium silicon as a repellent of spotted wing Drosophila?
I have not. I know there's been quite a bit of research on Ecotrol. I think even the University of Minnesota has been doing some work on that. And that's been shown to work pretty well, but I don't know where it's at as far as recommendation. I know nothing about potassium silicon, so I can't answer that, but there's been quite a bit of work on Ecotrol. Annie, did you hear anything?
Yeah, you kind of said it already, but I was just going to say to address the research that's been done on that at U of M, and they have found that it repels SWD in raspberries. However, it did not repel SWD in blueberries. And because of that, we don't have recommendations yet. We can't widely recommend something when we don't know why it's acting in one fruit crop and not another one. So we don't know whether or not it's going to act in strawberries. But we have applied for additional research funding to hopefully look at that. We also need to do more work to see, like, how often do you need to apply it, and how long does it work, and at what rate to apply it. So at Mary Rogers' lab at U of M is the lab that I'm referring to. And I don't think they've written like an extension article about the results yet. So I'm just going to put into the chat the journal paper, which is a little heavy to read, but if you want to dig into that, you can read about it here.
Thanks, Annie. That's great.
Great. So the other thing that I don't see any other questions, but I just wanted to let everybody know, the attendees know, that we will have another webinar on April 29 on organic pest management strategies for blueberries. If you're interested, we have an invited speaker from the University of Michigan State University, Carlos Garcia Salazar. And I'm just going to put a link in the chat on where to register, and also to our other webinars. We will have 2 other webinars in this series. And so if you're interested, here's the link. I just pasted it on the chat, and you can register there. We'll make announcements through our newsletters and our Twitter accounts. So if you miss it, it's going to be there. It looks like there's one more question. This is for Leslie. Do the disease that you presented apply to day neutral strawberries too?
Yeah, that's a great question. They do. They're the same diseases that day neutral would get, but management is a little bit different because, right, with day neutral, it's more of an annual cycle. So you're actually just removing the plant, which means oftentimes you can remove a lot of the debris that you'd otherwise have to try and remove that would be having overwintering inoculum. So same diseases, a little slightly different on the management strategies.
Perfect. So I guess that with that, we've answered all the questions. We will post this recording of the webinar on our website, and we can also put that in the chat here on our YouTube channel. We have one hosted by the University of Wisconsin-Madison and one by UMN. So Annie, I don't know if you want to put a link there. It's probably going to be posted within the next couple of days. And so I'll put another link here in the chat to UW fruit website, one of the resources there. And I'm sure that Annie can also put the one for UMN. And so with that, I'm going to stop the recording now. But before that, just thank everybody that participated and our speakers today for sharing all the knowledge. I'll just stop here.